Hi everyone, we are VR Prototyping Group. Product design at a later stage is an iterative process between prototyping, review, and refinement, of which prototyping demonstrates the feasibility, efficiency, and user-friendly of the design. However, it involves intensive test and error procedures, which is expensive and time-consuming. Alternatives such as low-fi prototyping is of low fidelity but with its physical embedment, while interface design tools such as Figma can provide interactive hi-fi prototyping, yet without physical embedment. But what if we take one step further, test the product in virtual reality with immersive experience as well as high fidelity but still at very low cost? Prototyping in VR can let designers avoid extremely error-prone iteratives, potentially problematic physical microcontrollers, hidden transitions, and so on, but more focused on design, interaction, and provide immersive experience. In this project, we redesigned the bot machine. Our aim is to provide time and cost-efficient rapid prototyping workflows by using VR to simulate both hardware and software of the prototyped device. Previously, the general workflow of prototyping is combining CAD models and UI design, and fabricate, finding problems, and came back to redesign, which is time and cost-consuming. Instead of doing physical prototypes back and forth, we introduced Unity in the iteration loop for prototyping. User would provide a Figma project that would then be rendered on the screen of their prototyped model. From here, we would map user interaction with Figma canvas to change in hardware state, physical and economic elements, and find any potential deficiencies. With Prototype VR, the iterative design loop can be largely accelerated, and the cost for physical prototyping will also be reduced. Next, we present a small demo of our project.
We first showcase how a user is placed in a realistic environment, detailing a potential advantage of running user testing in VR. In front of the user, we see the 3D model of a prototype BART machine that has a realistic physical body, some movable buttons, and a digital screen rendering Figma UI for HCI testing. For our project, we wrote a Figma to Unity plugin that takes Figma transitions and maps them to collision events in Unity. This system is very powerful as it allows designers to easily simulate business logic that would otherwise have to be implemented using microcontrollers in 3D printed parts. Instead, we take the business logic present in Figma and directly import it into Unity. As the user will now demonstrate, this system can generalize to collisions of any kind, including a card tap. This portrays the flexibility of our plugin that allows designers to simulate not only physical knobs and buttons, but also many kinds of sensors. Of course, we wanted buttons on the Figma screen to also work in our VR system. In this next demo, we explore the efficiency and effectiveness of A/B testing in Prototype VR by disabling the physical buttons on the BART machine and using a different Figma file to simulate a touchscreen-only interface. Our plugin also supports these buttons in combination with physical object interactions, as seen in the previous demo. We also implemented an alternate way of interacting with these prototypes in VR for designers who wish to give users more precision in selecting UI elements. Here, we use a VR pointer and cursor system that works just as well as the pointer ball shown before. Again, this exemplifies the flexibility and efficiency of Prototype VR to quickly alter characteristics of a user tester's experience. Some drawbacks of Prototype VR are that it's currently not friendly to non-developers who are not familiar with Unity, and that there are limitations to the types of interactions that can be mapped. Currently, we only support collision detection and click events, but many smart devices of the future will utilize more nuanced and advanced interactions that will be difficult to simulate from a Figma prototype to a 3D Unity system. However, despite these drawbacks, we conclude that Prototype VR shows great potential to not only speed up drastically the prototyping timeline, but also to introduce various flexibilities and advantages involving changing modes of interaction, maximum control over a virtual testing environment, and the smooth integration of software and hardware of a smart device. We believe that Prototype VR is therefore a promising exploration of the future of rapid prototyping.